Hello everyone, this is Puya. Today we're just going to review the concept of template classes and template functions in C++. So just let's see what the motivation for template classes and template functions are. So we have two pieces of codes on the left and right side of the screen. If you look at it, like we have a class with three private member variables and 4 member functions, and here you see the definition for a couple of the member functions here. The other two were defined inside the class. Now if we see these two classes and their member functions, we'll see that everything is almost the same in these two classes. The name of the classes, of course, are different. The other main difference is that the data type is different. So here we have a primitive data type integer. Here we have a non-primitive data type, let's say v3, three-dimensional vector, for example. And the same thing you see, like this is just a name, this is just a name, this is the data type. Here you have integer, here we have v3, integer, v3. This is like, you see that this is passed by value, passed by reference, and the same story. So these two classes basically do the same thing. The only difference is that they operate on different data types. Their functions also take different parameter data types. They might also return different data types, but they do the same thing, but like on different data types. So if in a program you need both of these two classes, if it's not for the template classes, we have to write these two classes, though they are very similar, right? So the template class and template functions provides capability for us, instead of writing multiple classes which are going to do the same thing, or multiple functions which are going to do the same thing but on different data types, they're going to operate on different data types, we are going to just write one template class, okay? And we leave the data type as something that can be instantiated later, that can be determined later, as we want to instantiate objects of these classes. So that's the motivation for having a template class. So we just basically say that like these two, the only difference between them is like the different data types. It would be just like nicer if we can define a template for like a Q class, for a class with a generic data type. Let's call it T, or we can call it anything we want. And T can be determined when you want to instantiate objects of that class. So the mechanism that C++ provides is called template class, and it's a foundation for generic programming. It means that you write a general program that would operate on different data types, primitive or non-primitive, and you can instantiate objects of those classes of different data types. So this basically shows the template class version of the same two classes that we saw in the previous slide. So what we just did, we wrote the same thing, but anything that was a specific data type, we replaced it with something that we call a type name. So we called it like here we called it T, but we can call it anything you want. It's very common to call it T because it basically shows that this is a template class, and this is just like a type name that can be determined later. So how can you make a class a template class? You just have to provide this line before the class declaration. Here we are just putting it on the same line. It's more common to write this line on top of the class Q here. Okay, so like it's very common to have like separate these two. It doesn't matter though. So this is one way of writing it, like, or you can just write this line separately on above the class declaration. Okay, and what you see here, like here, like where we had integer or integer or v3 v3, we replaced it with t. What is t? We don't know. Whenever we want to instantiate an object of this class, when we want to declare an object, we have to specify what t is. So here you see that we defined the constructor, default constructor, and the non-default constructor for this class. But for the insert and remove functions, we only did declaration inside the class, and they're defined outside the class. If you want to define this member function outside the class, look at the format. You have to again provide this line for each of the member functions that are going to be defined outside the class. So you have to say that this is a template class, T, and you also have to pay attention to this part. Now the name of the class includes this angled bracket T, so that we know that this is a templated class. Okay, the rest of it is the same as before. So you just have to pay attention to these two. One other thing that I wanted to specify, don't get confused. These two classes, they have different meanings. Here, this is the name of, this is the class that we just used in object-oriented programming. This class, and sometimes people write type name instead of writing class. It just basically means data type, right? The name of the data type that we want to make it variable. Okay, so though they both called class, but they have different meanings. This one is a class in the sense of object-oriented programming. This one is just a type name. So when a class is templated, it requires the template prefix just above the class declaration. So here we did it on the same line, but it's more common to have it just above the class declaration. All its member function declarations inside the class declaration do not need the template prefix. So you see that like here in the declaration, we didn't need to provide this prefix. But implementations of member functions outside the class declaration will require the template prefix for each of the member functions independently. So here you see that like we provided the prefix because we are defining these insert and remove member functions outside the class. Importantly, any friend function that's declared inside the class requires the template prefix. So if this class has a friend function, you just have to make sure that you provide the template prefix anyways. Even if you just provide the declaration of the friend class here, so you just have to provide the template prefix as well as its implementation outside the class. So if it's a friend function, both the declaration and the definition, they need to have the template prefix. How do you instantiate objects of the template class? So as mentioned, like here, T can be any data type. So when you want to instantiate object of the class Q, the templated class Q, you have to specify what the type name is. So here my int q object is an object of class q where t is going to be integer. On the other hand, my v3 q object is an object of template class q where t is going to be v3. What is the advantage of that? It's just like basically a generic way of writing program. It just reduces repetition of code. We don't have to write the class twice. Okay, and it just basically helps us to write a generic program, and we think at an abstract level. We don't have to focus on the data type. What is the data type? We'll see that how this is going to be helpful also when we want to write functions. So this provides two examples of template classes. So here we have class test. Again, it's a template class. See that like here the prefix declaration is one line above the class declaration. T is the data type that's going to be variable. And when we instantiate test1, we say that, okay, we want for test1, t is going to be float. For test2, it's going to be a character. Okay. Also, I wanted to show you that we can have multiple data types in the template, prefix. So here we say that, okay, we have two variable data types. You can have as many as you want. So t and k are both going to be member variables of this class. We don't know what their data type is. When we instantiate objects of this class, we're going to specify what t and k are. Okay, and here you see the non-default constructor and a print function, print member function for this class. And you see that here we specified that, okay, t is going to be float and k is going to be boolean for test1, and for test2 t is going to be string and k is going to be character. We can also have template functions. Okay, so like even if you don't have any class, let's say that we want to write a function that prints something, right? And when we print it, we don't care what the data type is, we want to print it accordingly, right? So this is a template function that just basically counts n, and we didn't specify what the data type of n is. It can be integer, float, string, character, whatever. And here, so we say that, okay, we want t to be integer. So although this argument is 5.5, it's going to print 5, because what's going to happen, it's going to cast this double number as a integer. Here, this is double, this is float, so it means that we want to call this function, but we want n to be float. In this one, we want n to be character, so that's why like you see that it prints A, which is the ASCII code for capital A is 65. That's why like here you would see this, and here like you would have a string. Can you tell me why these are highlighted in blue and this one is not highlighted in blue? Can you think about that? Because these are primitive data types that the C++ compiler comes with, but this is a class that has been defined in the class string. It's not non-primitive data type. How about this one? Look at this. I forgot to specify what the data type is, what t is. So in this case, and I didn't get any error. So any number that you write, any floating number that you write, by default, it's going to be a double data type. So here, your template function can infer that this is going to be double. So automatically, it would set t to be double. The same way here, I forgot to put a string here, but anything that goes between double quotation, it's going to be a string. So here, like you would know that this is going to be a string and it would print 5.5. Another example here. So we have two print functions. One of them is templated, one of them is non-template. Okay, excuse me. So here I'm definitely calling the template function and I'm asking t to be replaced with a string. Here I'm calling the template, t is going to be integer, t is going to be character. How about this one? Which function would it call? It would call the non-template version because this is integer, right? And it's going to call this one. I didn't specify the data type here, so I don't have any angled bracket with the data type between them. How about this one? So what if I want to call this function, right? But if I don't specify the data type, again, it's gonna call the template version because of these two angled brackets that I put here, and it's gonna use the inference to know this is gonna be an integer. And here again it's gonna call the non-template version because a is integer and I didn't specify what the data type is, and there is no angled bracket here. Okay, so just wanted to show you that like we can also have two functions with the same name, one of them template, one of them non-template. That's okay. So this is another example here. So you're gonna have like lots of examples for template classes and template functions. This is a example of a function that would swap two integer variables. What if I need to have another function that swaps two double variables or two character variables? Would it make sense to write this function 3 times? No. What we do is basically make this a template function. We would have a template prefix. We just have a type parameter here, so which we called it t. It doesn't have to be t. Okay, it's very common. It's a good practice to make it clear. So this is known among all programmers that this is going to be like representing a type parameter, but you can call it whatever you want. Just like wanted to make this clear. So this prefix tells the compiler that the declaration or the definition that follows is a template, and tells the compiler that t is a type parameter that's going to be determined later. In this prefix, class means type, right? It's different from the class in the sense of object-oriented programming. And you can, instead of writing class, some programmers prefer to write type name. Both of them are allowed. Okay. Mostly this prefix is more common, and this character t can be replaced by any type argument. Okay, so like you can just call it, for example, tmp if you want, but it's not very common. A template overloads the function name by replacing t with the type used in a function call. So when you call the function, this is like talking about the template functions. If when you call the function, you just have to specify what the t is. T is the traditional name for the type parameter. Any valid non-keyword identifier can be used. So as I mentioned, like any string that can be like a valid variable name can also be used as the type parameter. Okay, so here, like we just, when we call that template function, like the calling is similar, is like the same as before, right? But the compiler would know that because ch1 and ch2 are characters, it's gonna change the t to character. And here, because n1 and n2 are integer, the compiler would know that t is gonna be integer. You can also have multiple parameters, as I mentioned here, like you have, like we already saw an example using that. So using a template function, as already mentioned, we can express more general algorithms in C++. So for example, if you have a sort function, you can make it a template function so that it doesn't matter what kind of array is sorting. Is it an array of integers, or array of floats, array of characters? You can write your program more general. Algorithm abstraction means expressing algorithms in a very general way so we can ignore details. So just basically concentrate on the most important parts of the algorithm rather than just concentrating or focusing on the data type. So here, this is an example from a textbook. So here, we have, for example, a function, a template function that would basically find the smallest index, the index of the smallest number in an array, and it doesn't care what the so here it doesn't care what the array is made of. And you can see that here, it's not using T, it's using base type. That's okay. Okay, and base type would be determined when we call this function. Similarly, we have, I'm not sure what kind of sorting algorithm this is. Looks like a bubble sort. Yeah, so what basically this one does, it sorts an array. It doesn't care what the data type of array elements are. It would just sort that array. It can be integer, it can be double, float, character, and so on. And when we call the functions, it's going to be called the same as before. We don't have to worry about anything. Okay. When defining a template, it is a good idea to start with an ordinary function that accomplishes the task with one type, and then modify your code. So maybe just write your function for one specific data type and then make it general. Already mentioned that templates can be used for any type for which the code in the function makes sense. It doesn't have to be only primitive. It can be primitive or non-primitive. But let's look at this one. For the swap function that we saw here, let me go back. This swap function, it swaps v1 and v2, right? But if I call that function like this, I would get an error, because A and B are two static arrays or non-dynamic arrays, and you can never change you cannot assign A to B or B to A. So this would cause an error, right? So you just have to make sure that you are aware of what's happening inside your function and all the operations that are done. So here, for example, the assignment operator, does it work on the data type that we want to pass to the function? It doesn't work for static arrays. If they were dynamic, because it would be a pointer, variable pointer, it can be changed. But here, it wouldn't work. Class definition. So here, we talked about functions. Now here, I want to reiterate that class definitions can also be made more general with templates. The syntax is very similar, so you just have to use this prefix before the class declaration. So this shows a class called pair, and we made this a template class. So T is the type name, is the parameter type that is going to be determined when we instantiate object of this class. This shows basically how when you instantiate objects of that class, you have to specify what the type parameter, what the parameter type is, what the type name is. And after that, like you would just like use those objects the same as before, right? Like now this is just basically an object of class pair where t is integer, and you can just use it as we did before. So like you don't have to change the rest of the program, like everything works the same as before. So this is because this is important. I'm gonna repeat this part. So member functions of a template class are defined the same way as member functions of ordinary class. The only difference is that the member function definitions are themselves templates. Excuse me, template function. So here you see that like now I'm defining this is the non-default constructor for the class pair. So here you just have to make sure if you're defining it outside the class, you have to include this prefix. You also have to know that the name of the class includes this angled bracket parameter type. If this was done inside the class, if you define the member function inside the class, we don't need them. We don't need the prefix. We don't need this one. Of course, we don't need the scope resolution as well. So basically, this shows one of the member function definitions that's defined outside the class. You will see that like it has a template prefix. It would also have the angle bracket t is part of the class name now. So you will see that the name of a template class now can be used as the type of a function parameter. So here I would just like have a function called addup. What is its parameter? It has only one parameter, which is of type pair. What is the t? It's going to be integer. Replace that integer. And you can see that you can pass by reference, value, pointer. So all of the pass methods would work with the templates as well. You can also see that the return type can be just like the parameter type that we specified. Okay, so like you can see that this can be also the variable data type that just depends on how you instantiate the object. Like when you specify the data type and like what the t is, like all of them can be determined at that point. Regarding template classes and inheritance, so I have two examples here. So look at this one. Like, so class A is a template class. Okay. Class B is inherited in the public mode from class A, but in the version of A that t is integer. So class B itself is not a template class, right? There's nothing unknown about it. Like we know that t is going to be integer. Okay. However, in the other example, you would see that B itself is a template class. It's derived from A, right? But t is still like t, right? Like we didn't specify the parameter type, the data type, right? So here you would see that this B is derived from A, itself is a template class. So you can have like both of these depending on your application. One other concept that I want to mention here is that you guys remember about static member variables of a class. Static member variables of a class is a member variable that doesn't belong to, like, we don't have a separate version of it for each object. It belongs to the class basically. All the objects would share the same thing. Okay, so here, for example, in this template class, we have a static member variable. It's public for some reason, and it's count, right? So the class would share this with all its objects. We only have one copy of it. We don't have like each object would not have a separate count. We only have one count for the class, and all the objects would share that. But one thing we have to know is that each version, each type of the class would have its own static member variable. So here we would just have test int a, which in this case it would have test int would have a separate count. And you see that like as soon as we instantiate this object, count becomes 1 because it's calling the constructor, default constructor, count becomes 1. And we instantiate another object of the same data type, right? So it's gonna be count becomes 2. But when you have another object with a different data type here, the different type name, sorry, then this one, this class, this version of the class would have its own static member variable. So you see that like this one, count for this class now was initialized as 0 and becomes 1 at this point. And if I print them, you would see that like you would print 2 and 1. You would have two different counts, one that belongs to this version, one that belongs to this version. And if we had multiple test classes with different data types, we would have multiple count member variables. These are for your information. So we can pass non-type arguments to templates. Non-type parameters are mainly used for specifying max or mean values or any other constant value for a particular instance of template. What do we mean by non-type argument? Look at this one. I'm calling this function, this template function, and look at it. It says class T, comma, integer max, right? So this is the non-type argument, right? And when we call this, we have to pass a constant number to max. So this is possible as well. So the important thing to note about the non-type parameter is that they must be constant. Compiler must know the value of non-type parameter at compile time, so even before we run the program. Okay, so this just like this is for your information, but this is possible. If you see something like this, this is non-type argument. This means like we usually specify that for a constant parameter of the function. Another thing that's only for your information. So let's say that we write a general function for sorting, right? It's a template function for sorting. It gets an array of any data type and its size and sorts it, okay? But what if like for a specific data type we want to have a different implementation, right? What if like for character data type we want to have a different implementation of sort function? It is possible. So we call this template a specialization. So this function would only work for the data type character, right? So like for any other arrays of other data types other than character, this function would be called when we want to sort it. But if we want to sort an array of characters, this is how we specialize that template. We just like say that, okay, no, yeah, for like every data type I want to use this one, but for this one this function might not work, so I want to use a different function. So that's possible as well. This is a good example from Dr. Yunus's notes. I highly encourage you to go through this and just like understand what's happening here. This is basically similar to class of vectors that we can use, but like this in this example it is shown how we can implement it ourselves. But one thing I wanted to show you here is that like here, like if you have a friend function, you have to provide the template prefix, right? For other member functions we didn't have to, right? But like for template we have, for friend we have to. Excuse me. It shows the implementation and definition for member functions here. I'm gonna skip through them. And this is another good example that we did in CMPT 135. So this example with the comments provides the description for the problem, and it would ask you to just basically implement all the member functions and the friend function. So it's a good example if you want to practice working with templates, but we use this for another course, so it's okay if you skip it. Using template classes and friend functions, template classes and friend functions, it's sorry, I should say friend function. It's a little bit beyond the scope of the course, but if you want to learn more about it, we already mentioned some stuff about it, but if you want to learn more about it, you can just check out this very good link here. So now let's just like talk about separate compilation. So we mentioned that in object-oriented programming, one of the principles that we want to apply is modularity. So we want to separate each class into two files. One cat, let's say like the name of the class is cat.h, so one h file, header file, that would have the class declaration, and one CPP file that would have the member function definitions. And so if you're not familiar with this part, we want to make sure that we don't redefine a class. So we just like say if not defined something, which is like this is like a common practice that we just use the name of the class with a underscore with a capital H, so cat.h, which is the name of our file. In some versions they don't put the second underscore, in some versions they do. So we say if this is not defined, define it, and this is end if. So this prevents multiple definitions of the same class. Let's say like you're working on a very big program, you're in charge of one class, another person might be in charge of another class. We don't want to have these two classes to have the same name. So if you follow the same protocol, the program makes sure, the compiler makes sure that one of them is going to be skipped. So and it would give you the warning message that this was skipped, right? In the newer versions of C++, instead of these 3 lines, you can just like say pound pragma once. So we just like make sure that, because like here, like we have to make sure that everybody follows the same protocol. But instead of these 3 lines, you can just like have one line on the top of your, in the beginning of your H file, header file, saying pragma once. So, but basically this is what we have. If we have, you can see that we have one cat.h file, one cat.cpp file, and here like we have all the non-member functions, which is the main basically. Now separate compilation allows us to divide the program into parts. Each part can be stored in a separate file, so it would just like basically make our program modular, and we can just like assign like each task to like a different person, or like we can just debug the code much easier. And a class definition can be stored separately from a program. This allows you to use class in multiple programs. So that's another advantage of separate compilation. However, when it comes to template classes, unfortunately there's a problem with the separate compilation and template classes. So when instantiating, so this is like taken from this link, that's basically a Stack Overflow post, and has like many good answers here, like many good points are mentioned here. I highly encourage you to check this out. But basically, like when you define your template, when you declare your template class separate from your CPP file, the compiler needs to have access to the implementation of the methods on the same file to instantiate them with the template argument. If these implementations are not in the header, they're not accessible to the compiler, and therefore the compiler wouldn't be able to instantiate the template. So you would have most probably a linking error. Okay, so there are a couple workarounds for this. One solution for it would be just making sure that when you have when you have like a common solution to this is write a template declaration in a header file, then implement the class in an implementation file. So it can have, like, for example, that it can be like a TPP file, okay, and include this implementation file at the end of the header. So like basically letting the compiler know that the implementation, it's gonna be in this file. Okay, so this basically shows, this one shows the header file, this one shows the TPP file. Okay, so like provide the implementation in another file, and like provide and let the compiler know that, okay, so the implementation of this class is in the other file. This way implementation is still separated from declaration, but it is accessible to the compiler. So just wanted to give credit to Ms. Jiangyi and Dr. Yunus. Just like some of the slides in this lecture was taken from their lecture notes, and these are like very good links for review, so please check them out. Thank you so much. If you have any questions, I hope I can answer it once you ask them for me. Thank you.